So we talked about what would happen if you have aerobic respiration. So if there is oxygen as our final electron acceptor, and we have mitochondria in this particular organism, then we can do aerobic respiration, the Krebs cycle, electron transporting, chemiosmosis, and all those other things. But what if we don't have oxygen? So what would happen is, first of all, this would be in anaerobes. So this would happen just in the cytosol. You don't need to have organelles to do this. And what would happen after glycolysis is fermentation. So you have your pyruvate, and it's not going to go to the mitochondria. Instead, it's going to be converted into either lactate in lactic acid fermentation, or it's going to be converted to ethanol in alcohol fermentation. And that's actually how we make alcohol from yeast fermentation. When it's breaking up into ethanol, we also have carbon dioxide that's being made, because remember, ethanol has 2 carbons, whilst the other carbon has to go somewhere. So this also makes carbon dioxide. But these products are not so important. They're actually byproducts for the organisms making them, right? What's the purpose of this? Well, isn't your glycolysis giving you the 2 net ATP? And I mean, unicellular organisms can live off of that. It's not very much energy compared to like the 30-something made in aerobic respiration. But for them, that 2 ATP is enough. So why do fermentation? Don't you already have your ATP? Well, the problem is when you're doing glycolysis, what do you need to be able to do that? You need these NAD+, and these to be able to go and get reduced, become NADH, so that you can carry out the reactions. But how are you going to get those NAD+? Eventually, if you just keep doing glycolysis, you'll run out. So we take those NADHs, and we're going to regenerate the NAD+. So that is the purpose of fermentation. So some cells are facultative anaerobes. And what that means is if there is no oxygen, well, that's okay. They'd be able to just switch over to fermentation. An example of that would be our muscle cells. So say you're in an emergency situation, or you're just doing vigorous exercise and you're running away from this bear or whatever, and you're just using up more oxygen than you're actually taking in. So there isn't enough oxygen to undergo oxidative phosphorylation and get ATP that way. So instead, you're just going to get ATP from glycolysis. Now, to keep glycolysis going, we're going to need fermentation. So our muscle cells actually do lactic acid fermentation. And that's what's going to give you, at the end of the day, like, it's not giving you the 30-something ATP that you'd be getting from like full-out aerobic respiration, but at least you're getting those 2 ATP to get you going through just past that finish line or away from that bear.